Good afternoon, YouTube. Welcome back. Hopefully my audio is a little better today. Again, this is my second video ever, so I'll get better at it. Anyways, today I'm going to be going over a little bit more of the capturing software that I wrote, and I'm going to go through a calibration and a little bit of the equipment that I use in order to capture these cymatics. So we'll just go ahead and jump right in. The first screen that's going to come up here is going to be some of the equipment that I use. And I'll be doing full videos on a lot of this stuff, the relevant stuff. But for today, we're going to be focusing on this right here, which is the signal generator. And of course, that just came up. We're going to focus on this signal generator right here, and then we'll also focus on this little amplifier right here. So it's important that these two are kind of in sync with each other because depending on what frequency band you're working in, the amplitude's going to change a little bit. So the lower the frequency, typically, you could use the little bit higher of an amplitude, and we'll go over some of that here in a little bit. So I'm going to go over some of the calibration process. Right here, I'm going to show you a chart that I typically build before I get into it. And basically what I do here, and the way that this chart is set up, is I set my amp, which is the little dial that I showed that's actually on the Cymatic box. I set that to a given um, setting, and at this point it was at 47%. I'll then take that signal generator, and on the frequency side, I'll go to my target frequency. For this case, it's 9. And then I could adjust my amplitude to whatever I want. So what I'll do is having the manual amp set at 47 at frequency 9, I'll find where the cymatic starts and where the cymatic ends. And then I'll move to my next frequency where it starts and where it ends. And this will all make sense in the next screen. I'm sorry it sounds a bit confusing right now, but as we work through this exercise, you'll see kind of what I mean. So this is the script that I use for capturing these cymatics, and this is raw data. This isn't um, the entire AI system. So what I'm putting in here is I could do as many sweeps as I want. This particular one is going to be 3 sweeps. We're going to be working in this area here. So my start frequency is 24. I'm going to go to 25, and I'm going to be going in steps of a tenth of a hertz. The amplitude is going to be between zero point 0.9 and 1.2, which is these guys here. And then the amplitude step size is only going to be 0.05 volts. And then each one of these steps, I'm going to sit for 15 seconds before I capture. And now step 2 of 3 is a bit larger because, as you can see, all of this is the same. So I'm going to just do one entry for all of this. So that's starting off at 25 hertz and going to 34. I'm going to be scrolling through these or sweeping through these at zero point 0.1 hertz, and the amplitude is going to be zero point 0.8 to 0.11, and I'm going to be going from 0.8 to 0.11 in 0.05 volt increments. And let's going to go ahead and start here. Again, you'll notice in the previous video, I bring this decay down a little bit. What this is going to do here is kind of even out the image a little bit. And once I go ahead and start it, right now this is below what I call the breaking point of the cymatic. It's just about ready to start moving, and as you'll see, every 15 seconds, this number is going to go up. And I believe with this particular frequency, when we get to maybe 1 volt, it should start breaking. So we'll give this another couple of seconds here, and then you'll notice the cymatic just start to form right before our eyes. This one's pretty cool, I believe. And yeah, you can see the line starting to form here, and then it just pretty much does it automatically. Okay, so this one was 1.05 volts. So my calibration was a little off on this one, but throughout the entire data capture, it gets a little bit more accurate. And just for AI purposes, it's actually really important that you have bad data as well, because again, we're just capturing all of this data and feeding either good data or bad data to the AI algorithm. So as you can see, that popped up at 1.05, and as soon as we start getting beyond that, it starts getting a little grainy. So what I did there is I switched from the AI NVIDIA capturing stuff to my live camera feed. The frame rate's a little off right now just because I'm using a capture card, but this is what it looks like live. You could see the cup here springing along, and this is again the live feed. And when I start actually capturing like true cymatics, this is what I'm going to be producing. Right now we're in more of the data collection phase. And again, what I'll be doing with all of this information is feeding it to the AI engine and getting it to learn these cymatics through and throughout. So when we do get to the point where I'm going to be looking for really nice crisp data, I'm not getting a bunch of noise. I'm not getting a bunch of garbage. And one important thing to note is right now, things like the cup size, the amount of water that's in it, the chemistry of the water, all of these things are kind of arbitrary right now, just because I'm trying to teach the AI. So once I get comfortable with the intelligence of it and how powerful this device actually is, that's when I'm going to switch gears into the more scientific way of doing this and really capturing, okay, I have exactly 14.5 milliliters of water in this cup size that's made of this material. And another thing that I found is if you add a little bit of dish detergent, specifically Dawn, it gets rid of that surface tension and you'll get a much more uniform, good looking cymatic. So that's something that I just picked up a couple days ago. What I'm doing here is I've switched over this. I found a really cool cymatic here, and I wanted you to see it live form. So these are those rings without that decay feature going on. Again, this is live video. So as we start increasing the amplitude here, we're going to see a pretty cool cymatic just form right before our eyes. These are the kinds of things that I love about this science. And you know, this is raw data straight from the camera. The frame rate again is a little bit low, but once I identify where all of these kind of interesting patterns are, that's when I'm going to do the deep dive in with all the really nice lenses and really high frame rates and really capture it. So the data entry or the capturing side, I could be a little messy with it. Um, and as this gets refined over time, we'll really dial in, and I think that we'll be able to capture some really cool stuff. So that was that particular cymatic here. Um, and so what's going on now? I shouldn't have actually fast forward there, so we'll go ahead and just let that play out. I'll go back to here. So now that I've captured that particular run actually wound up taking about 3 hours, 3 to 4 hours, something like that. And once it was done, I come back and I get into the sorting software, which is this here, um, here you go, dataset sorter. And all this is, again, like I mentioned in the last video, is my raw data. So over the past 3 to 4 hours, I captured 842 pictures. And I just set my hand on A and D and drinking a cup of coffee, click D or A. If I like it, it's an A. I'm sorry, if I like it, it's a D, and if I don't like it, it's an A. Just back and forth like that. And that usually, you know, I think I got this through this one in, you know, 20 minutes or so. And once what I'll do with that is that all goes into those two folders, and my next script that we'll be running probably tomorrow will take that information and make intelligent decisions on what is a cymatic and what is not. And we'll do the first run of that tomorrow. So look forward to putting that video together for you. To wrap things up here, I'll go ahead and find some of the cool ones that we just found on this particular run. Saw some ones with like a 3-top here towards the end, I believe, which were really cool looking. Yeah, so some of these came out really cool, and it's a lot of fun doing this stuff. So I hope you guys are enjoying it as much as I do. I really look forward to getting a nice, respectable data set together that could be used for whatever research out there. I'll be publishing all of this stuff on my site. The site's going to be innovativecymatics.com. I just bought the domain last night. And yeah, I look forward to sharing this data and getting scientific with you guys. Till next time.